Okay, so I just want to review this math because I don't know if I'll get a chance to do it in first period, but I know we'll not be here in sixth period to review it. So I just want to go through. The very first question says the diagram below shows the range of tolerance for soil moisture content for two different species and terrestrial invertebrates living in a temperate forest, species 1 and species 2. The ranges are represented for each species where it occurs alone. Soil moisture content is a limiting factor for both species. Okay. So what we're going to do is we're going to look at where the peak is for both of them because that's where the tolerance range is. I couldn't draw an exact straight line here, so this one might actually be 4.25. You'll have to kind of eyeball it and see. But nonetheless, for species 1, I've said it was 3. For species 2, I've eyeballed it at 4.5. So I find the absolute difference, and that is 1.5 bars. So right here it says absolute difference. Okay, so that's absolute value and subtraction. Okay. And the next one it says soil moisture is determined by several factors, including precipitation. The temperate forest has an average yearly rainfall of 95 centimeters. Calculate the monthly volume of water absorbed by a plot of land that is 14 meters long and 12 meters wide. Assume all rainfall is absorbed. All right, so we're going to say for this one, we're going to start with 95 centimeters. And I'm going to say 95 centimeters of rain in 1 year. And then I'm going to have to make that meters. So then I'm going to say 1 meter is 100 centimeters. So that will get rid of my centimeters. And then I want it monthly. So I'm going to have to say 1 year is 12 months. And then I'm going to multiply it by the area, which I said 14 meters times 12 meters is 168 meters squared. So that's 168 meters squared. So I'm just going to multiply that across and cancel. So multiply across 95 times 168, I get 15,960, and that will be meters times meters squared. So cubic meters, and then across I would say 100 times 12, and that will give me 1,200, and then I need to divide 15,960 by 1,200, and it looks like my final answer should be 13.3 cubic meters. Okay, so the next one says these are 5 islands A, B, C, D, and E differ only in the distance from the mainland and species diversity. The table below gives information about the distance from the mainland and total area of each island. Identify the island that would be predicted to have the lowest species diversity and the highest. Okay, so we know the lowest is going to be farther away and smaller. And so the lowest is going to be D. So lowest, maybe D, is it is farther away and smaller. And the one that's going to have the highest is going to be largest and closest. So the closest one and the largest one is going to be B. So we'll say that. Then it says calculate the percent difference in island area between the two islands that you identified. Okay, so this one's a little bit different. So we're going to do the difference, the percent difference, over the average and times 100 to do this one. So we'll say 1 times 10 to the 6 minus 1 times 10 to the second. It doesn't really matter which way you do, just do absolute value. And then we're going to do over the average. So that would be 1 times 10 to the 6 plus 1 times 10 to the, oops, sorry, write that wrong, times 1 times 10 to the second. And then we're going to divide that by 2, right? And then once we get that, we'll multiply that times 100 to get our percentage. So we're going to do the average on the bottom rather than the starting point. And that's because we're trying to get the percent difference in area. So we need to do the average for this one. So we'll subtract 1 times 10 to the 6 minus 1 times 10 to the second, and then we'll divide by the average, and you get about 200%. So plug that into your calculator. Okay, so according to the species area relationship, the number of species has a logistic relationship with area. The average number of species found on the mainland to the nearest to the 5 islands is 0.78 meters squared. Assuming all species have an equal chance to migrate, calculate the possible number of species that could be found on the island with predicted highest biodiversity. Okay, so the highest biodiversity is B, and that's 10 to the 6 hectares. So we'll say 1 times 10 to the 6 hectares. Okay, now it says we got to get it to meters squared, so you got to look up what that one is. And so you can say 1 hectare equals, let's see, I think 1 hectare, yeah, 10,000 square meters. That's 10,000 meters squared. Okay, and then you want to say there's 0.78 species and on each square meter. So then you can multiply across. You could also have said, let's see, times, and you could have done 1 square meter, and that would be 1 times 10 to the negative fourth. I probably wouldn't have done that one, but either way, you should get the same answer. So when you go through and cancel, hectare is going to cancel, and meter squared, so hectare, and then you would end up with your number of species, and you get 7.8 times 10 to the 8th species, no matter which way you do it. I think you should get the same answer. Okay, so for this one, we want to talk about the one that has the highest biodiversity and which one has the lowest biodiversity. So the index are already done for us here. So obviously, highest biodiversity is going to be here, and lowest looks like it's going to be right here. Okay, so we've got that. The next one says calculate the portion of all individuals counted in this survey that came from a beta, and I don't know if I'm saying that right. All right, so let's see how many individuals came from that area. So we'll go here, and it looks like we have 5 and 118 and 214, 229. And plus 229. So we add that up and divide by 1095. Okay, and the 1095 or 1095 is the total number that's in. All right, so if we do that, let me punch that in. You get 566 over 1095, and so 0.52. Okay. The second question says calculate the percent difference between the average Simpson's index. Let's see if I can clip the question. Oops, missing a C. Calculate the percent difference between the average Simpson's index for the Zelinki area and the Trehe area. And again, I'm certain I'm not saying that correctly. So first we have to do the same thing that we did for the Abeta area. And so for Z, we'll just get the numbers for that one for the indexes. Now this, we're not doing the total population, we are doing the indexes. So that would be 0.32 and then 0.42 and 0.56. Okay, and divide that number by 3. It looks like I get about 0.43. And then I'll do the same thing for the tray. Okay, so that would be 1 plus 0.52 and 0.19, 0.19, and 0.34. And then we'll divide that by 4 because there's 4 values to get the average there. So the average for that is 0.51. Now then I'm going to find the percent difference, and as we did before, we're going to do the absolute value of the difference over the average. So I'm going to say 0.51 minus 0.43, and I'm going to do over 0.51 plus 0.43 divided by 2, right? And then multiply by 100. When I do that, then the percent difference is about 17%.